screen. I'll open Discord now. Can you tell me if you're seeing my VS Code? Yes, good. Okay. So, my name is Boris. Today, workshop will be about practical use of RAG using 3 tools. This event is made by the Techna Big Data group. This is the second event about RAG. There was one that was streamed from Trondheim a couple of weeks back, I think, before Easter for sure, where 2 companies, I don't remember exactly which ones, they were presenting sort of theoretical inspiration side to RAG and some of sort of tools like BM25 for parsing text into sensible chunks so it can be retrieved in a smarter way. Today, I will show specific use cases, or one use case really, is getting information from PDF documents. And these PDF documents are quarterly releases, financial releases by companies. So I can already sort of allude to what it's going to be. So we'll be looking into data that is for quarter financial reports from 2024 by Equinor. Similarly, Kongsberg, 4 quarters in 2024, and Telenor, 4 quarters in 2024. And I can show you examples of those reports. So if you open Equinor, for example, again, apologies, this is a new computer for me. I'm not used to working on this computer, so I might not know how to do certain things. So here is an example of a PDF published by Equinor showing their financial status in 2024 second quarter, downloaded from their webpage, from Equinor's webpage. So in terms of the data itself, we see that it's unstructured. There are images, there's text. The sort of the formatting of the text is unpredictable. The tables are not as you would usually see in Excel sheets. There are graphics. There are sections that are sporadic. They're just spread around the pages. And so on. So you can see that the bottom line here is that the reports are unstructured, that contain text, images, and tables for the main part. So this is just one example. And then to make things even more complicated, I suppose, is if you open, for example, Kongsberg quarterly reports, the formatting of those reports would not be the same as Equinor's reports. So, I mean, the data types are similar. You have tables, you have text, you have images, but the formats or the spreading around the pages is different. So this is the data that we'll be looking at. Right away, as you might know, that unstructured data is complicated to work with. It requires pre-processing for most of the time. And it's hard to predict the outcomes. If, for example, you would think, okay, how do I parse such a document to extract specific sections. Or for example, if you load a PDF into a Python, how would you search for a specific text if you don't know what the text says exactly? So for example, if you're looking for revenues in financial documents, maybe they are not presented as revenues, but you would have to do calculations. So if you search for revenue in the document, you wouldn't simply find anything. But if you search for price, earnings, etc., you can do your own calculations to arrive at specific sort of values that you're interested in. There's no specific reason why I chose financial data. It's just it's my personal interest. I was thinking first to do academic papers, but then the methods that I was using, I had to adapt a lot of stuff to specifically academic papers because they're more structured, if anything, really, because they have specific sections. Sections are called specific way. They have, paragraphs that can be if anything, the BEM25 approach for chunking the data would be more appropriate there. But here, okay, let's jump more into the actual code. I'll share the link in chat to a GitHub repository where you can download and run the code yourself. Today, I'm not going to be running, unfortunately, because I had to use a different laptop and none of the environments are set here. But I have luckily yesterday saved the outputs to show what you would expect as an output. To some of the things, not everything, unfortunately. So the first thing, as I said, we would have to do data processing, pre-processing. So these are PDF documents. Now, when you have a PDF, unless it's a PDF generated from SVGs, for example, those are simply just images in the PDF, so you can't read the data from them. You have to do OCR, optical character recognition. You have to classify different types of objects you're looking at, if you're seeing tables in the documents, if you're seeing images, if you're seeing text. And it's very, very hard to do it yourself. For some time, the state of the art was to use easy OCR to do classification of images, for example, or PDF documents, where you detect things and classify. You do fine-tuning of the easy OCR. However, recently there was a new library that's called Spacey. Spacey is a natural language processing library that deals with text classifications. So it can classify things like parts of speech in sentences, etc. And there was a extension to this library, Spacey Layout, that was working specifically for classifying parts of documents or images. So if you have a PDF, Spacey Layout can detect sections, paragraphs, headers, find images, find tables in your documents, which makes it much easier to use such a library rather than do it yourself. So in this case, we're using Spacey Layout, and we'll be using a sentence transformer, all mini LM version 2, which has a dimensionality size of this model is 384. So the vectors returned from this embedding model would be of size 384, which is somewhat appropriate. If you look at the documents, you would see that most of the time the sections or the paragraphs, they are not too long, not too short. they're about, I haven't made the statistics of the length of the text, but from what I've seen, it's never a beyond, it never goes beyond like 500, 600 characters per paragraph. Tokens, I mean. So the it's in my opinion, it's appropriate to use this model to generate embeddings from these documents. And the reason why we'll be doing generation of the embeddings is that we'll be searching inside those embeddings when we will be posing specific questions to those, when we'll be chatting to those documents. I'll be using LlamaIndex to generate a vector store of those PDF files. The reason is it's coming more from my personal experiences, is that LlamaIndex is good at generating vector stores because you can add additional information on top of it. You can add metadata, and you can enrich the data with extra information. So it's simply my own preference to use LlamaIndex library in order to generate vector stores from the data. So now let's move to the main part of the code, which, well, here we have a for loop. So we'll be iterating the data folder. We have Equinur, Kongsberg, Telenor. For each of those folders, we'll find the files, obviously, PDFs inside each folder. Then we'll use spaCy layout to consume each PDF. This is stored in the doc variable. And then from this doc variable, we're only going to be extracting text data and table data. So if you look inside the text data method, here we have, so spaCy layout produces an object which allows you to look at spans. So it classifies everything as a span. And in that span, it provides a label. So it does classification of what the item, whether it's looking at the graphics, whether it's looking at, okay, I can see that Anna is pinging me. I'm just going to open. Yeah, so people are asking for the URL for the repo. I will provide this information after I'm done. Or okay, I can actually maybe do it right away. Here is the URL. Let me just paste it into the chat. There we go. I hope people can maybe take it together with me at the same time. spaCy is going to classify all the pieces of information in the PDF document. Either it's going to be a text, list item, in the paragraph. So this is the text data that we'll be looking at. I believe there are few more labels like header or title. I'm not looking at those. This is, again, this workshop is just an example. If you would adopt this code to use in your own projects, you would have to write or create more, rewrite the code in a better way, just that suits your specific needs. So now what we are outputting is a dictionary in this case, where we have a heading as a key in the dictionary, and the text of that span, in this case. Oh, okay. I can see Discord. I see. Okay, okay, yeah. Sorry for that. New laptop, hard to do things right. I hope you can see me and VS Code at the moment. For the text data, we have a dictionary where the key of the dictionary is the heading of the text area in the PDF document, and then the value is the actual text of that span or paragraph or section. So this text data, very simple. Now, in order to process tables, it's a little more complicated. Let's go inside that method. And this is the way I decided to do this. It doesn't have to be the same way if you do this. So spaCy layout classifies things as tables, and then we're going to iterate all the tables. For each table, we get a heading, and then the data of the table is in pandas format. So we have a data frame, and what I do here is I process, so I iterate over all the previously stored or remembered tables, and I compute their similarity. The reason I do this is because I noticed that in those documents, in the reports, sometimes tables are repeating, specifically like sections where you have table of contents, they appear on each single page. So here I'm removing, or I'm simply not using the duplicates, and here I'm using a specific value of 0.6. After I was testing this, I decided to use 0.6 to just discard all the tables that are similar to the ones I've already seen in the document. If the table is unique, I am appending the heading and the actual table into a list. Here I'm doing a little bit of cleaning. Sometimes the columns of the tables can be similar or same. I'm making sure here that if it's a table, that all the columns in the table would be unique. So this command here, tdup names, it just simply creates postfix for each column name. And then I'm dropping all the, or replacing here all the empty fields of the tables with nonce, and then I'm dropping the rows of each table if most of the values are, or half of the values are empty. This is just my personal way I decided to do this, just by looking at the data. And of course, again, if you use it for your own experiments, you would have to adapt these things. And here I am converting the pandas data frame into a dictionary. So now for each table, each table is saved in this variable here, where the heading of the table is the key, and the table itself is the value, and the table here is the dictionary. So this is it. And now, so we collect text data, we collect the table data, and then we make Llama documents. So let's look inside this method. This code here commented out because it's simply for debugging purposes. I haven't, if you run it yourself, you will be able to see in tables text what's actually stored as a document in the vector store. In this case here, for the tables, df row heading, sorry for strange names, but it's the names I decided to use. So for each table, I'm creating a document where for each table, its table name is the heading of that table, and then I'm storing the name the names of all columns into a column attribute in this dictionary, and the rows for each. So it's going to be a list of columns and the list of rows. And then I'm appending additional metadata, which in this case is very simple. It's the name of the company, which comes from the subfolder. In this case, it's Equinur, Kongsberg, or Telenor. Doc ID is, in this case, table underscore the heading of the table. The source is the it's just the name. So in this case, it's going to be, for example, Equinur underscore 1 is the source, and then the year. So here is something actually not correct, because initially when I ran the code, I was running for different years. In this case, there is no year, unfortunately. So this would actually be not year, but the quarter. Similarly for the text. So here we store, we create, or we have a list of documents where we first process all the tables, and then we're going to process all the text. So all the text will be stored as the heading of this text and the value of the text. In this case, the metadata is similar to what we're storing for each table. And after we make Llama documents, so it's just a list of documents, and the document is the data type from the LlamaIndex. We're going to be using Phi's vector store because it's free. There are a lot of other vector stores that are more advanced. Some of them you would have to pay for, but we're using Meta's Phi's vector store, which is very simple to explain. If you want, you can read about it. It's a very simple index vector store database where we have 384 dimensions for each data item. This is boilerplate code here. So we have storage context from LlamaIndex that allows you to store stuff in the local storage. Then we create vector store index from our documents. This is a list of documents that contains both tables and the text. And then we make it persistent. So we store everything inside the data encoded folder, which contains subfolder. So for each company, so if you look inside now, data encoded, we have the same structure. We have Equinur, we have Kongsberg, we have Telenor, we have quarter, in this case 1, and we have the data associated with the vector store. I'm not going to be looking inside the JSONs. It's what you would expect from what LlamaIndex creates when it creates index vector store. So this is it. It takes time to process. Just keep in mind when you will run it yourself, if you don't have a GPU, for example, because SpaceC layout can use GPU but doesn't need to. If you run it on a CPU, it will take time. So be patient running it. Close this file. And now let's move to the actual RAG. As I said, we'll be looking at 3 different libraries. One is going to be DSPy, LlamaIndex, and LangChain. Everyone has their favorite. I'm not going to go into details what those different libraries do and what's the difference between them. I can just name quickly, is saying that DSPy is focusing on prompt engineering as a programming. So you would program your prompts and you would make sure that the data types are always ensured the correct way through Pydantic interfaces. LlamaIndex is probably more standard, sort of older way of doing RAG, because we already use LlamaIndex for generating vector store. I decided that it makes sense to also include LlamaIndex as a RAG agent. And LangChain is a big player. Some people hate it, some people love it. I also decided that it makes sense to include here. And actually, in terms when we'll be looking at the LangChain, it's going to be more of a agentic workflow. So I'll be touching more on the how to create an agent that does multiple iterations in order to collect all the data to answer a question. So let's start from beginning. Here we have, I define a class, LLM with tools. In this case, tools will be our index vector stores for each company. And here I'm saying that whenever you use the LLM with tools, you have to provide your LLM instance. It's going to be either DSPy LLM instance, or I guess I should have named it more agent instance, but never mind. LLM instance, we perform LLM setup. We'll look into individual classes for each individual library, how we do setup. And then we perform ask operation, where you ask your question to the agent of each individual library that in turn will use its own the vector store. So let's first look at the DSPy. We have a DSPy LLM class. Let's go inside there. So what happens here? First, we have to load our vector stores. The vector stores were stored using LlamaIndex. In this case, I'm going to use LlamaIndex to restore the data from the local drive, from the data encoded folder. It's the init. So whenever you start the DSPy LLM or create an instance of the DSPy LLM, the first thing it will do, it will load the vector index store. So here I'm saying that I'm using Hugging Face embedding model for the embeddings, same as I used for actually writing the embeddings. It's the same model, all mini LLM version 2. Then we're gonna look inside the data encoded folder, take all the subfolders. So for each subfolder, for each subfolder, so you get it, it's the name of the company and each quarter. So for each quarter, we are gonna load the vector store that is stored in the local directory using face vector store class, because we used face vector store to store the data when we did pre-processing. Then it's the same boilerplate code, so we make sure that we read it from the local storage, and then we load index from storage using this storage context. So once we have the index, we are going to create a list of tools for the agent to work with. In this case, I call them all query engines, which might not be accurate naming, but for each of the index, I get the retriever of this index, and I say that for each query I will post to it, I want 5 results of this of my query. So it will look for 5 similar items in the vector store. You can say you only want only want top 1, and it will only return to you, for example, the top 1 result that is appropriate to your question that you're asking the vector store. Here I'm doing some cleaning. Okay, someone's asking a question, I believe. Let's see. No sound. So some people experience problems, and there's a window that is blocking. I'm using, you see, I'm using Teams to have a video of myself. Is it looking better now? Sorry for these problems. Okay, looks like it's working again. Let's jump back into the VS Code. So here I'm doing a little bit of garbage collection because initially when I was testing with a lot of documents and I was running out of memory. So I just made sure to delete. You don't have to do it if you're just having a couple of documents probably. So after you run the initialize the DSPy LLM, you have all queries engines list with each item being a vector store for each quarter for each company. So it would be a list of how many items. If you have 4 quarters for each company, 3 companies will have 12 items in our all query engine. So now let's look back into what we do here. We say that we create an instance and then we call setup on this instance. So now setup for the DSPy, we are going to create 2 predictors. One is going to just be a simple predictor. Predictor simply means called to the LLM. And the other one is going to be chain of thought. Chain of thought does an additional step. It simply does, as far as I remember, it says that predict and think about what you predicted to make it as simply as possible. But it would probably work similarly if you, use predict instead of chain of thought. I believe so. Chain of thought is just, it does an additional step in the instructions to the LLM. So here we have generate an answer and then summarize the answer. So now what those who are familiar with the DSPy, you have to provide signatures where you basically specify the prompt to the model. So when we want generate an answer, we want to find the best data source. So it's a best data source guesser. It's a DSPy signature. And in this case, we're saying, you are an expert information retriever specialist. Can I make it word wrap here? You're an expert information retriever specialist tasked with evaluating and selecting the most relevant information from multiple data sources. So if you remember, we have 12 data sources for each quarter for each company. And here we're saying your primary responsibility is to analyze the user's question and match it with the most appropriate retrieved information. When evaluating the response, consider relevance to the user question, accuracy and completeness, and reliability of the source. We have 3 input variables. In this case, it's the question from the user. It's the retriever information. It's a list. So we have a list of descriptions for each retriever. In this case, it would be, for example, one of the descriptions would be, you are the retriever that has information about Equinor Q1 or first quarter data. So that would be the retriever information. It will have the 12 retriever informations. And the answer would be also a list of the same size, where it's going to be the responses from each of those retrievers. And then we want our guesser to provide the best answer number. So which retriever produces the most accurate answer to our question. Since we're using DSPy has a retrieve class so we're extending here the retrieve class, and because we're using llama as a retriever, so we have to cast it in a way to the DSPy retrieve class. And in this case, so retriever, self-retriever is our llama retriever, LlamaIndex retriever, where we say that for each query, we're saying, okay, llama, provide me. So actually in the background, it's the llama that does the retrieving part. And then the DSPy simply judges which retriever produced the best possible or the best answer to the user query. So generate answer is simply generating 12 answers for each retriever based on our question. And then we're asking DSPy to use data source retriever summarization, because as you remember, for each retriever, we retrieve 5 closest items from the index store. So here we're saying you're very good at summarizing multiple sentences into a paragraph, because basically what it is, it's sentences. It returns 5 different sentences that are closely related to the user query. So you're very good at summarizing multiple sentences into a paragraph given user question list of sentences. Make sure to summarize a sentence into a paragraph that answers the user question. And as an input, we have the question from the user, all the answers. So we have 12 answers, and we have, already in this step, in the data source retrieve summarizer, we have only 5 answers because we already selected the best retriever here. So it's 5 answers, and then we provide the summary. So basically summarizing those 5 answers into one. And that is it. And the return of the ask function is the summary. So if we now look into what the DSPy here does, we're creating the DSPy LLM instance, and then we're processing this question. So in this case, how Kongs were performed in the first quarter. And here, thankfully, before this event, I saved the answer I got from running this on my another computer. In this case, the answer was, in the first quarter of 2024, Kongsberg achieved robust growth in the beat and the beat margin driven by its largest business areas, especially Kongsberg Maritime, blah, 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 with some numbers. I haven't verified this. You can look into actual documents and see if you can find this information in the PDF, but I assume it should come from the PDF and not from somewhere else. So this is it. This is how it works using the DSPy, or the way I implemented it in the DSPy. I've been using 2 predictors. One predictor was guessing which retriever produced the best answer based on user question, and then the next predictor was just summarizing the answer from that predictor that was considered the best one. Okay, so we're done with the DSPy. We're moving on to the LlamaIndex. In this case, again, we're using LLM with tools, and we're creating an instance of the LlamaIndex LLM. So let's go inside the LlamaIndex LLM. You would notice right away that the init method is it's pretty much the same as the init method of the DSPy, because we need to load the data from the vector store on our local drive. So we're doing it here. I'm not going to go through this again because we already did that. So it creates 12 in vector stores that it stores in the local variable, in this case, all tools. Sorry, I'm using different names sometimes because I was writing those codes at different times, so my brain was in different places. And in this case, because we're using LlamaIndex, we are using LlamaIndex query engine tool. So for each tool is a query engine tool where our vector index, we are getting query engine from our vector index with the similarity top k being 5. And the reason we do this, the reason our tool is a query engine tool, is because when we are going to do setup, we are going to create a router query engine. So that's another class provided by the LlamaIndex. And what this class does, if you remember what we did with the DSPy, the first thing we asked it is to select the best retriever from a list of 12 retrievers. So this is exactly what the router query engine does in the background. If you look in the source code, I believe there is a instruction somewhere hard-coded in the source code saying that select the best retriever from the list of retrievers. And in this case, our list of retrievers is query engine tools, which is all tools that we created previously, with each tool being query engine tool. That in turn contains a query engine. That's our index vector store with a similarity top 5. And in this case, since we have many tools with many vector stores for different companies, I tried use case where I want to answer, get an answer to a question how different companies compare to each other. So I'm going to use LLM multi-selector, which will provide me not just one best retriever, but perhaps multiple retrievers. Sorry for naming. So I was testing some stuff. It doesn't have to be two here. It should be query engine. I'm asking the query engine or our router query engine to answer my question. So I'm querying the router query engine. And if you look in the retriever demos here, so we're processing question. Here I'm asking, which company, Kongsberg or Equinor, had stronger financials in second quarter? And the answer is Equinor had stronger financials in the second quarter, demonstrated notable improvement in its adjusted net debt to capital employed ratio, and achieved 3% increase in revenues compared to the same period. In contrast, Kongsberg reported negative quarterly EBIT in 125 million NOK, despite positive growth in its EBITDA. So what happens in the background, or what happened in the background here, is that router query engine selected two retrievers. It decomposed my question into two questions. It asked first Equinor about its financial performance, and then it asked Kongsberg for its financial performance, and then it compared the two. So this is probably the most minimalistic code that I've seen so far in different libraries that allows you to do cross retrieval, and then doing the comparison. So it's getting closer to the agentic workflow where you have one big question that has to be decomposed and you have to use different tools in order to answer your question. So that's our LlamaIndex. And now we're going to move to the LangChain. Again, we're going to use LLM with tools. I should have had a different name here, perhaps LangChain LLM instead, to be similar to the previous ones. But anyways, let's go inside the LangChain code. So here you see the same thing happens in our init method. We are loading all the indices, all the vector stores. So 12 index vector stores. And then for each vector store, we get the query engine. And this query engine is now going to be wrapped with index tool config. Index tool config is something specific to the LangChain. It allows you to turn your tool into a query engine, actually. LangChain has a bad reputation of naming things, similarly as I do. But basically, index tool config is a query engine. And you can see that, yeah, it requires a query engine as a parameter, where we provide our vector store query engine as an argument. And then we provide additional information. I believe there are two ways you can do index tool config. It's either query engine, it's this, or you, keyboard not used to this computer. Where is it? Here, I believe you can say just metadata equals, and then it's a dictionary, and then you can have name equals performance, etc., etc. But I used this version where you specify name, description, tool, quarks, which actually aren't needed here. I was testing some things out. We only care about the name and description, and we don't really care about the sources in this specific use case. So the name of our index of our query engine is company. In this case, it's going to be Gunnar Kongsberg Telenor financial reports for 2024 quarter and the number following here. And you can provide a description saying that this tool helps answer queries about this company, quarter, this quarter, report for year 2024. The names and the descriptions, they don't have huge effect on performance, but you should be writing sensible information in them for each tool, because the router, or in this case, it's going to be agent action, because we're talking about LangChain environment. They will be looking at the descriptions and the names of each tool or each index vector store in order to decide which one it should use to answer your question. So then the tool, in this case, we're turning LlamaIndex tool. So the LlamaIndex tool has a method that converts LlamaIndex tool into LangChain index tool. They kind of work together. There's a lot of methods across the libraries in order to make sure that you can use LlamaIndex and LangChain together. So in this case, for each tool, we're turning it into a LangChain tool and appending it to all tools list. And here I'm also removing some of the stuff which isn't necessary. Now what happens in the setup? We create our LLM usually, and we create a agent chain. In this case, what we want to do first is, I was interested in looking at the intermediate steps. So I want the LangChain to have a variable where it stores intermediate steps here. And because I was thinking more about agentic workflow, where each next step or each next step of the React agent will look at the previous step, and then you have to format your log to a string so that it can be used as an input into the next step of the reasoning by the agent. And I'm using a financial analyst prompt, which I'll show you shortly, where I provide all tools as an argument, and I'll show why. And then I'm saying that I'm going to use this LLM, and then I'm just simply, I will show you simple parser. It's a method that simply outputs everything out. I'm not doing any parsing specifically here. I'm just pushing everything into the output further. So I'm wrapping my chain into agent executor, where I provide the agent, the tools. I say that I want to get back the intermediate steps. I say that I don't want it verbose, because otherwise you'd get same output. You would get output in one color saying all the reasoning, all the verbosity of your agent. But instead of that, I simply output a variable that contains all the strings into the method or into the class that called this agent. Handling parsing errors with LangChain is very important, because LangChain can fail in many steps in its agentic workflow, unfortunately. And sometimes you have to write some magic here to make sure you do parsing properly. But in my case, when I was testing this, I didn't need to write any extra stuff for parsing. So just handling parsing errors is enough. If there's a try-catch block somewhere that raises an exception, it will simply do the agent executor, create the agent executor again, and do the LLM loop again. And here I'm saying that don't do more than 10 iterations in case if you fail 10 times. So just keep doing this infinitely. And here, when I'm asking the actual question, I'm calling my chain with invoke method. There's no chat history. I wasn't interested in chat history in this specific use case, and I'm passing input to the user question, and then the result of the chain, I'm just looking inside the output variable of the agent after it has run. So now let's look at financial analyst prompt. It's at the top of this class, I believe, here. So our analyst prompt is, you're great at financial analyst. Let me wrap the words. You're a great financial analyst that's amazing at analyzing annual reports, use revenue, profit, EBITDA, income, cash flow, earnings, blah, 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 and to answer any questions, whether technical or general. Answer the following questions, performing proper research and using all tools. So here I'm being very conservative. I'm saying that use all tools at your disposal just to make sure it doesn't skip any of the tools, any of the 12 tools that I've given it, and all my 12 retrievers. And here I'm saying you have access to these following tools, and it's the list of tools, the class names of those tools, basically. Use each tool at least once. So I'm being very conservative here again. I'm saying that make sure to look at every retriever. And here is the agentic workflow. I'm saying, okay, use the following format. It's the question that the user asks you, think about it, think what you should do. You think if there is any action you have to take. So here I'm giving it tool names, which is to our 12 retrievers. The input to this action, the observation from this action, and make sure to repeat this n times. So you keep repeating this action observation loop until you have all the until you have all the answers to sub questions. And then thought, I now know the final answer, and the final answer to the original input question. Begin. And then again, I'm being very conservative. I'm saying that reminder that you should use all the tools available to you. And then the user question and the thought. So everything that goes inside the thought is this intermediate variable that stores all the reasoning done by the LLM. It's called usually agent scratchpad, but it have to be called that way. And here, so I'm creating the prompt with tools being LangChain has a method saying render text description, so it uses just those descriptions and names for each tool that we created when we were creating the tool for the LangChain with the LlamaIndex. So the tools is a description of those tools, and the tool names is just simply we're looking at the name of the tool. And then the get prompt, where we get the full string with all these variables filled in. And then the final thing is that I said after the agent is done with this iterations, in order to find answers to the questions and sub-questions, I'm saying that I want to parse the output, and the output usually has content variable, which is just the whole thinking process of the agent. It also has to have a log where you basically send the same stuff. So the return value is the output dictionary with the key output, where the value is the content of the output of the agent. And if we look into what we get, so here I'm asking the same question: which company, Kongsberg, has stronger financials in second quarter? Sorry for the formatting here, but you can read and see that first it does thought. To determine which company has stronger financials in the second quarter, I need to analyze the financial reports for Kongsberg and Equinor for quarter two. I will compare key metrics such as revenue, profit, EBITDA, income, cash flow, and earnings. I'll start by reviewing Kongsberg's first. So here it says action. Company Kongsberg financial report for 2024 quarter two. Action input, analyze key financial metrics such as revenue, blah, blah, blah. Observation, Kongsberg. So here it gets actual data from the PDF or from the vector store and the beta, etc. And if you go further, you can see that it does the same thing for the Equinur. So Equinur is quoted through reports, show the following, revenue, blah, blah, blah. And then the final answer. Where's the final answer? Here's the final answer. Equinur had stronger financials than Kongsberg in the second quarter of 2024. If you're interested in looking at more detailed description, I suggest just copy and paste it into a text editor and format it so you can see the thinking process by the agent. So that is it. That is everything that I wanted to share. You have the code available to you. I provided requirements here because it's Python. That's what you usually do. I think I added everything here, but I might have missed some small things. So if you get an error saying that something is missing, just do pip install. Again, we have LangChain, we have Spacey, we have Fies, and Llama. And the DSPy, actually, I think the DSPy is missing here. So this is it. I think we're exactly on time. I'm not sure if there'll be questions. Let me read the question. Okay. From what I understand, becomes part of the context window sent to the LM, which actually use it for creating more relevant answers. I'm not sure which one you're referring to, but yes, all of them operate with the instructions sent to the LLM that contain the description of what the task you're trying to solve. And in case of, for example, LangChain, it actually performs reasoning inside the instruction. And then you have on one side retriever and the question. You could generate embeddings for those two. You marry them together. You get the top K 1, 2, 3, 5 answers. And then you try to sort of reason based on the answers you get from the retriever. Right. I will try to add versions to the requirements. Yes, I'll try to do that. Sorry for not being a good programmer. What is your thought about how to evaluate RAG systems? That's a interesting question. So for example, in DSPy, there are some instructions that you have to provide in order to get what you want. So DSPy provides optimizers. In the DSPy, you have optimizers that can optimize instructions. So then the question is like, okay, how would you optimize those instructions? Because you can write whatever you want and however you want. What I've done in similar projects is you have ground truth. It would be something like, I'm looking for this piece of information in a document, and you provide actual snippet from that document as a ground truth. And you would use that as in the optimizer, and then you would use some kind of semantic similarity search. DSPy actually implements semantic similarity search to give you a sense of how similar the two text pieces are. So that's the first thing that I would do, for example. Same question as Egil. Have you tested different embedding models for Norwegian text? No, absolutely not. Sorry. Just simply no. There are, I believe, embedders for different languages. I don't know if Norway has one. If there's a Norwegian one, I know there's a Norwegian language model, but I don't know if they have a embedder for Norwegian language specifically. I assume there are some researchers that work on that, but I don't know of any commercial or open source model that works well. Another point to make here is that when I started writing the code, I was ambitious and I used some of the open source library, some of the open source LLMs, forgot which one. Forgot which one I used, but I used some 2 billion parameter model. Don't do that because they are bad at generating formatted text like JSON, and LangChain, LlamaIndex, they operate at the JSON level, which means you'll get a lot of errors. So if you're thinking about running something like virtual LLM library in order to host your own LLM and then do the RAG, you will have to write you would have to write your own parsers for each of the output from the LLM, which is can get very difficult very quickly. So here's a question. Have you tried unstructured API from LangStar? Can't remember the name now. Or PDF miner for parsing VS Spacey. No, I haven't tried. I think I have heard of those. No. There are a lot of tools and ways. And I actually just recently discovered Spacey layout. I knew about Spacey, and I think it's amazing because I remember struggling parsing PDF documents previously, doing own classifications and fine-tuning easy OCR and this stuff. I think from my experience, Spacey layout actually works pretty well. Of course, not amazing, but good enough for parsing PDFs. Sorry for sitting like in the corner and the screen. I would have to change some of the settings to make my face on the whole screen. How important is the size of the text chunks after parsing? Yes, very good question. Very important, because think about it, like if you have just like a couple of words in each chunk and you're using 1,000 dimensions in order to encode that, you just have a bunch of zeros. Or the opposite, if you have too much text, like thousands of tokens, and you use small dimension to encode it, then you would lose some details in your data. So in my, like when I was writing this, I was thinking which embedder to use and how to parse text. And then when I started getting sections from the PDFs, I noticed that they are about like 300, 400, 500 tokens per, or let's say words per section at most. I just thought that, okay, I'll just use the mini LLM. Okay, I shared the code with you. Look at it. You can always write me a message if you need more explanation. And thank you for joining. I think someone's typed. Okay, thank you so much. Yep. Thank you for joining and have a good day.